I had problem 721, which is the n equals 20 observations are to be taken with a variance of 1.4 and let the sample variance denote the 20 measurements. So I had to find A, B, and C. So for A, for uh, probability of sample variance less than B, it equaled 0.975. So to do that, I just do chi square dot IMV, and that is the 0.975. And then for degrees of freedom, it's n minus 1, so 20 minus 1 is 19. So that gives me 32.85. And then the formula to like find B, you would set 32.85 equal to the degrees of freedom 19B and divide it by the variance. So it's 1.4. So to find what B is, I'm just going to do 32.85 times 1.4 the variance. And then I'm going to divide that by 19. And that gives me B of 2.42. So that's what B is, which I'm asked to find in this situation. And then for A, it's kind of the same process. The only difference is we do the chi-squared in INV to the right tail because you're asked to find the right tail for this. So then you do the same, and it once again it still equals 0.975, and the degrees of freedom is 19 again, and that gives you 8.91. And then you do the same process where it's 8.91 times 1.4 the variance, and you divide that by 19 the degrees of freedom, and that gives you 0.66 rounded. And then to find the in between A and B for the sample variance, you do chi-squared distribution, and then the x is the formula like I just did for finding A and B, except you plug in what A and B were. So for B, that's going to be first. I'm going to do 19. Let me add some parentheses. 19 times the B, which is, I guess I can just do D1. And then you then divide that by 1.4. And then that's your x, and then your degrees of freedom is still 19, and then true. And then you do the same thing, but for the A variable, so it's 19 times A divided by 1.4, comma, 19, and true. Hit enter. And that is like 0.95 would be the total between the two. So A is 2.42, B is 0.66, and C is 0.95.